Physical science, electric current. So today we are going to learn about the electric current. So electric current means flow of electrons, electric charge in a circuit is called electric current. Already you learnt about the electric circuit in the 7th class. So this also given here. See here. So bulb is there and battery is there. So bulb and battery connect with the wire. So when we switch on, so the chemical energy from the battery converted into a electric energy, and this charge goes to the bulb and the bulb starts glowing brightly. When we switch off, automatically the bulb turned off. So this closed circuit converted the chemical energy into electrical energy and makes the bulb glow. So what is there inside the battery? Chemical is there. So this chemical energy converted into a electric energy and makes the bulb glow. When we connect the bulb and battery with a nylon, then you observe the bulb. The bulb cannot glow. Why? The nylon cannot pass the electricity from battery to bulb. Why? This nylon is a non-conductor. Copper wire is a conductor and nylon is a non-conductor. So these non-conductors are called insulators. Insulators means the metals which they cannot passes the current, so they are called insulators. Next, when we can take the pieces of wire, so here this is a pieces of wire. So here also in the diagram also we can see here is the current piece of the wire. So the piece of wire is like this diagram. So this is called open circuit. So inside the open circuit, so positive ions and negative ions are present inside the copper wire. Okay, so these positive ions are called lattice ions and electrons are called free electrons. Why? Because the electrons moves from one place to another place, so they are called free electrons, and positive ions are fixed in their locations. Okay, so the plus sign denotes as a plus, and these are called lattice ions, and electrons denotes as a minus, and they move from one place to another place, so they are called free electrons. So here also we can see the piece of wire. So in this wire also called open circuit, and the Drude and Lorentz scientist states that lattice ions are positive ions fixed in their locations, and free electrons move randomly in the open circuit. So here also we can see the positive ions in their locations, not moving. Positive ions not moving, then they are called lattice ions, and these arrow marks shows the free electrons. So these free electrons moves randomly. So this side and outside of the in copper wire. So when the teacher is not there in the classroom, the students are moves this side and outside of the room. So when the teacher came into the classroom, the students are sitting in the ordered line. Like that, here also the electrons move this side and that side. Okay, so this motion is called random motions. Next one, the Drude and Lorentz says that number of electrons crossing from left to right and right to left through cross section is equal. So net charge is 0. Net charge is 0. So when we see this piece of wire, so this inside the conductor, so the copper wire is called conductor. So in this copper wire, when we observe the inside of the copper wire, what is there? Cross section is there between the two ends. The cross section is there. So when the free electrons moves from left side to right side and right side to left side, so then the charging passed from left to right and right to left, so the net charge is 0. Okay. When these wire connected to the battery, so when we observe the electrons moving randomly inside the wire, copper wire, when we connect this wire to the battery, automatically the electrons moves in orderly motion. Okay. So these electrons moves from battery to wire and next connect to the bulb and reach the bulb, and the bulb glows brightly. So when connect the wire to bulb with battery, electrons move in odd motions. In the first diagram, the electrons in a random motion. When we connected the battery, then automatically the electrons moves in order motions and make the bulb glow. Here we observe flow of electric charge in a circuit is called electric current. So inside the wire we observe the positive ions and the negative ions. So different charges are present inside the conductor. So here electric current means Q by T. Q by T means Q means electric charge and T means time interval. So the charges move from one side to another side in 1 second. So it is called current, electric current. Flow of electric charge. Flow of electric charge in a circuit is called electric current. So this electric current measured units, SI units, ampere, denoted by A. Ampere is a SI unit denoted by A. And 1 ampere is equal 1 coulomb by 1 second. So 1 coulomb means 6.625 into 10 to the power of 18 electrons. So these number of electrons passes from one side to another side. So this is called coulomb. So one coulomb by 1 second is called amperes. Okay. Next one, here also we can see the open conductor. Open conductors means the wire not connected to the battery. So here the amount of charge that passing through a cross section in 1 second is called electric current. So the amount of charge that passing through a cross section is there between the two ends of the conductor. So the amount of charge that passing through a cross section in 1 second, the amount of charge passes from one end to another end, that is called electric current. Next one, charges measured in coulomb and current measures in ampere. So here charges are measured in coulomb. Next, current is measured in amperes. When we connect the conductor with a battery, so the electrons move in a order motions. So during this period, the electrons collision with a positive ions. So the motion of the electrons like this zigzag motion. So the electrons started moving from one place to another place, and next going to another place, next reached the zigzag motion in the conductor. So many electrons are there in the conductor, so we cannot measure the velocity of the electrons inside the conductor. So here we can take the average velocity. Average velocity means velocity of total collision electrons are called average velocity, and this average velocity called drift velocity. Average velocity is called drift velocity, and it is taken as a constant velocity. Constant velocity means total electrons present inside the conductor and the velocity of the total collision electrons are called average velocity, and also this velocity is called drift velocity. Now, formula of drift velocity. So formula is there for drift velocity. So here we first observe the diagram. So here this is a conductor, and this conductor connected to the battery. So here inside the conductor cross section is there. So here we can see the 2 points C, D. So the electrons move from C point to D point. So between these movements place is called distance, and the electrons moves from C to D in 1 second. So it is called drift velocity, Vd. Drift velocity means Vd. And this C, at the C point the cross section is there. And how is the shape of this shape is called cross section. Both sides this shape is has a cross sections, and totally the shape of this part is called cylinder shape. So this is a cylinder shape present inside the conductor, and in this cylinder shape the electrons moves from C to D point. So between these 2 points the place is called distance, and these electrons moves C to D in 1 second, so it is called drift velocity. And the whole shape is called cylinder volume. So the distance travelled by all electrons in 1 second is called Vd. The distance means C to D. This distance is travelled by all electrons. So many electrons are there here. So all electrons in 1 second is called Vd. And this shape is called cylinder volume. So cylinder volume. So when we can see the cylinder volume as a upright position. So base area. So we can say this part is called base area, and the height is called Vd. The height of the cylinder is called Vd. And how is this cylinder means upright position. So when this cylinder can see the upright position, so base area appear and height is appear. So this height is called as a Vd. So now cylinder volume means base area into height. Base area, the top part is called base area, and height means Vd. So A into Vd. So cylinder volume is AVD. Next one, free electrons for unit volume. So many places there inside the cylinder volume. So in this cylinder volume, a small part is called unit volume, that is N. N, total number of free electrons in cylinder volume. So a small part of the unit volume. So how many electrons are there? N electrons. And totally the number of electrons in the cylinder volume. So we measure the electrons present inside the cylinder volume. So NaVd. Total charge means NaVdQ. NaVdQ. Q means charge. Totally the cylinder volume has a charge, that is NaVdQ. So the current passes through this conductor is NaVdQ by 1 second. So Vd means drift velocity is equal to I by NaQ. NaVdQ by 1 second is a current, and drift velocity means I by NaQ. Okay, so here Vd means drift velocity, I means current, N means unit volume, A means cross section and Q is a charge. So here we can see the formula of drift velocity 1 by NAQ.